As manufacturers, we have to think about various manufacturing operations and how to reduce their costs. In today's episode, we dig a little deeper into the honing operation and listen to a story of how my company, Transor India, helped achieve a refrigerator manufacturing company significant cost savings. Honing is a high precision operation and hence it is relatively expensive. Therefore, it is done for components which demand the highest level of precision. It is an abrasive machining process in which an abrasive stone is rubbed against a metal surface to produce the maximum possible precise surface conditions along a controlled path. Amongst all the materials, cast iron honing poses significant challenges because of the brittle nature of cast iron. Whenever a cast iron component is honed, the dirt particles that get accumulated are in the form of dust. The size of cast iron particles after honing might range from zero point 0.5 to 5 microns. To give you a perspective of scale, a human hair is about 75 to 100 microns. So removing this dust from the cutting fluid or honing oil in this case poses a significant challenge for all manufacturers. Today's story is about a leading refrigerator manufacturing company placed in northern India that faced massive challenges in controlling their component quality after honing. They faced massive rejections in the cast iron cylinder blocks used in the refrigerator's compressors. The problem was so grave that the company's senior management and engineering team had to launch a company-wide project to find and address the root cause behind these failures. They analyzed each and every process involved in the compressor manufacturing. After months of careful data gathering and analysis, they finally came to the conclusion that the honing process had to be optimized. Further analysis revealed that the main rejection cause was that the cylindricity of the inner surface of the cylinder block was consistently being out of tolerance. After investigating the root causes, they concluded that the fine cast iron dust in the honing oil was the main culprit. At this point, it was evident to the engineering team of this company that the honing oil filtration system that they were using was inappropriate. Why? Mainly because it was incapable of removing the dust-like fine cast iron particles entering the honing oil. The filtration system that they were using was something like this. It was a closed loop circuit in which they were using a simple gravity filtration system called paper band. In this, the magnetic separator worked as a pre-filter, which removed coarse cast iron particles. After the magnetic separation, this honing oil entered the paper band filter, in which the dirty oil flows on the paper media and it traps, or it is supposed to trap, the fine cast iron particles. This system had two problems. One, even though the oil was passing through the paper media, still they could find muck or settled cast iron particles inside the tank. And two, the system was recommended by the honing machine manufacturer, and still they were facing this problem. These observations prompted the engineering team to look for alternative filtration solutions, and hence they systematically defined their problem state. They had come to the conclusion that any new system should satisfy the following criteria. One, it should double the average oil life, which was currently 4 months. That is, they were changing the oil every 4 months. Two, because of implementation of this new solution, the component rejection rate has to go down by less than 5 per month. And three, increase the honing tool life by at least 100%. During an engineering exhibition, this team visited my company, Transor India's booth. After looking at the various exhibits and understanding our capability, they narrated this problem to us, and thus began the process of solving this problem for this company. After witnessing the trial, the engineering team was absolutely shocked to see yellow, crystal clean honing oil coming out of the filtration system. The shocking part was that the input oil was end of life. Impressed by this solution, they decided to go ahead and install our system in their factory. After commissioning of the system, the performance was up to the mark. Our system was delivering crystal clean yellow honing oil to the honing area as witnessed during the trial. However, within 6 months, the filter pressure increased to such an extent that the clean oil flow rate coming out of the system was almost zero. Now, such early choking of the filters was not expected because Transor filters last really long for applications like these. As an immediate quick fix, we installed a new set of filter elements. However, before we could get to the root cause of why the first set of filter elements failed, the second set also failed within merely 1 month of operation. This indicated to us that there must be some other mitigating factors leading to such failures. Since two different, completely new set of filter elements choking at in the same manner at the exact location had never happened. We decided to launch a comprehensive study, and our senior management and engineering team rolled back their sleeves and decided to get to the bottom of this issue. Our engineering team conducted another round of trials at our own facility. However, during these set of trials, we decided to widen our scope of inquiry and include other inputs like the customer's honing oil, the brand that he used, as well as the amount of dirt or the honing oil cast iron particles that our filter elements can withstand. We made a list of various honing oil brands for these trials. We made a test replica of a system similar to install at the customer's location, and we used design of experiment method to consider various input variables for this study. The variables that we considered were as follows: the oil brand, the duration of the filtration cycle, the duration of backwash cycle, the compressed air pressure used for backwashing, and the filter element material. The output variable that we monitored through these studies was the rise of filter pressure. These trials took almost 2 months. However, at the end of these trials, we could see a very strong correlation between some oil brands and the rise of filter pressure. That is, some oil brands performed significantly better compared to the others. Another important conclusion that we could draw through these studies was that the filter pressure rise was slower when the amount of dirt coming onto our filter elements was restricted. We will provide a link to our findings in the description below. We presented these findings to the customer's engineering team and recommended to change the oil brand and to install a pre-filtration unit. The engineering team appreciated our sincere efforts in finding a solution and they agreed to all our recommendations. We updated our system with a fresh set of filter elements along with a new fresh honing oil brand and a very good rare earth magnetic separator as a pre-filter. The customer's engineering team keenly observed our new updated system for almost 6 months, after which they were ready to evaluate our solution with the selection criteria that they had laid prior to the starting of this project. And the results that they got exceeded their wildest imagination. They got an average honing oil life from the current 4 months to 12 months. The number of component rejection rate, which was ranging for about more than 100 per month, came down to less than 5 per month. And the average honing tool life improved from 1,000 to 5,000 hours. Moreover, the comprehensive study that we conducted on various honing oil brands led to the customer using our recommended oil, which was almost 20% cheaper than the oil that they were using. Hence, they achieved significant cost savings over and above their project objective. Our customer company declared that this project was a huge success. In my opinion, the major takeaway from this story is that when engineering teams collaborate, nothing is impossible. The passion to solve a problem is what makes us engineer, and we should be proud of it. I hope you enjoyed listening to this story. I am very passionate of such mechanical engineering success stories. So if you have any of your personal stories which you would want us to showcase over here, please write us in the comment below and we will